So as we move forward, playing with some other probability, again, remember probability is measures the chance that an event will happen. So the event is going to be then, the probability of the event is going to be, again, the favorable outcome divided by the total outcomes. So probability, of course, has a lot to do with playing cards. So this example is involving five card poker. A lot of times we call that five card stud. So find the probability of being dealt the following hands. Refer to the table. Note that a standard deck of playing cards has 52. So four suits, clubs, diamonds, hearts, and spades, where each suit has 13 cards. The ace, the deuce, the three, the four, the five, the six, the seven, the eight, the nine, the 10, the jack, the queen, the king. And remember, the ace can either be high or low, so they put it down low. So what's the probability of being dealt a straight? So they give us a table, the number of outcomes favorable ease. So a straight would be down here at 10,200. That would be the favorable. So they actually give us the math here already. So there's 10,200 favorable outcomes for that. That's a lot. Notice how there's 2,598,960 total outcomes. And they also say round to 8 decimal places. So this definitely sounds like a calculator problem. So I'm going to make my calculator a little bit bigger for you. See if we can keep this all here. So the favorable was the straight. So I'm going to put the 10,200 into the calculator. That looks right. And again, this calculator does not do commas, so don't put the comma in here. It's going to screw it up. So just no comma here when you put it into the calculator. Divided by the 2 million, the 598, and then the 960. No comma. It will not calculate it correctly. So we have that. We hit enter. And we have a big old decimal like they were saying. So we went around 8 decimal places. So I actually have to go 9 decimal places. So if we look at this, I had 0.00392. There's 5. 464. 464. And then that's what, 1, 2, 3, 4, 5, 6, 7. There's 8, but I have to go one more decimal place. So 0.0392464, then just a 6. So that ninth decimal place tells me how to round. So if it's 5 or more, we move this up to a 5. If this is 4 or less, we keep it as a 4. We round it back down, if you will. So since this is a 6, this says we're closer to the 5 than we are to the 4. So when we write the answer, then it's going to be 0.0039246, but that 4 there's got to move up to a 5. So would that be 8 places now? 1, 2, 3, 4, 5, 6, 7, 8 places. So that would be the probability of being dealt a, oops, I put that in the wrong spot though. We want to do a straight here. So that's up here, 0.00392. 465. 1, 2, 3, 4, 5, 6, 7, 8. The next probability is being dealt a full house. So a full house has a less likelihood. Remember, that's going to be a better hand because it's less likely to happen. So notice how this time we're going to have favorable outcomes is going to be this 3,000. Let me clear this off here. So the favorable outcomes for a full house is going to be this 3,744. And then we're going to divide it by the total of outcomes altogether, which again is this 2,598,960. Again, no commas, please. So 2,598,660. The commas just help me read it. So for the straight flush, I'm sorry, for the just the full house, we have 0.001. 440, 57, 6. So it's 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. That is 9. So what I have to do is look at this 6 and decide, do I round this 7 up or keep it a 7? So since the 6 is 5 or more, this tells me round that up to an 8. So 0.00144058. That 6 would say round up to an 8 since we're going 8 decimal places. So 1, 2, 3, 4, 5, 6, 7, 8. So again, 8 decimal places means to the right of the decimal. So we have that going on there. Okay, so I believe that was question 11 and 10 and 12 was what we was looking at there. So we'll stop there with those.